So today's lesson is about multiplying mixed numbers. There's a couple things I want to remind you of as we're going into this lesson that I think will really help you for this. This particular lesson uses a lot of models to help show what the fractions look like. One of the things I want you to remember is when you're working with a mixed number, you have a whole number and a fraction. You can change those whole number and fraction mixed numbers into an improper fraction, and it makes it a lot easier to work with when you're doing multiplication. So just kind of as a side note, let's do a quick review on how to do that. If you have something like 2 1/4 and you want to turn it into an improper fraction, a fraction where the numerator is larger than the denominator, you're going to be working in this direction, right? Going to be moving around here. You're going to be multiplying here and adding here. Okay, we've done this before, it's been a while, and you're going to be creating a new fraction by doing this. So we always start down here. 2 times 4 is 8. 8 plus 1 is 9. That's where the numerator comes from. Your denominator is going to stay exactly the same. Let's practice that a couple more times. If we have 5 2/3, and we're going to change it into an improper fraction where the numerator is larger than the denominator, we're going to be working again clockwise around this number. We're going to multiply here. We're going to add here. So 3 times 5 is 15. 15 plus 2 is 17. And you have turned that back into an improper fraction. Now, the second piece of that is being able to take this improper fraction and turn it back into a mixed number. So this part's helpful when you're doing the problem. The next part that I'm going to show you is helpful when you're finishing up the problem, because you want to finish it up with a mixed number. So I'm going to use a couple of different numbers. Let me grab a different color so I don't confuse you. Draw myself a little line here. All right, so this was mixed number 2, improper fraction. This side is going to be improper fraction 2, mixed number. Okay, say you have an improper fraction, which would be any fraction where the numerator is larger than the denominator. So say you had something like 8/3. What you're basically saying is your whole takes 3 pieces to make. You have a total of 8 pieces. So how many wholes could you make and how many pieces would be left over? The easiest way to do this is look at it just like a math problem. This is like saying 8. Imagine there's a little division sign here in the middle. 8 divided by 3. And if we do that math, how many times will 3 fit into 8? Fits in twice. 3 times 2 is 6. We subtract. This is our whole number, and we're going to take the remainder and write it on top of the divisor. Okay? So it's like saying 8 divided by 3. The way that you can think about this as a picture is, here's your whole. Takes 3 pieces to make a whole, right? You have 8 pieces, so if I had to show you visually what this looked like, I have to be able to color in 8 squares, right? Because I have 8 pieces and it takes 3 pieces to make a whole. So that would be just like this. There's 3 pieces, 4, 5, 6, 7, 8. If I was going to represent that with a whole number and a fraction, I have 2 wholes and I have 2/3 left of the last part. Okay? Let's do another one just to practice it. Say I have 12 sevenths. This is like saying 12 divided by 7. So I'm going to take my 12 and I'm going to divide it by 7. 7 fits into 12 one time. 7 times 1 is 7. You can subtract. That would be 5. I put my remainder, becomes the numerator, and my divisor becomes the denominator. Okay, again, this tells me that it takes 7 pieces to make a whole. So let's see if I can do this. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. These are not exact, I apologize, but you get the idea. I would be coloring in 12 pieces because I have 12 pieces, and it takes 7 to make a whole. So 1, 2, 3, 4, 5, 6. Oh, that one needs to be one longer. It's good that I checked. 7, 8, 9, 10, 11, 12. All right, so how many do I have shaded in here? I have 1 hole, and I have 5 out of 7 shaded in. Okay, so that's just something for you to keep in mind while we're working through some of these problems, okay? They are showing you another visual way to look at this, so we'll be working on that as we go here. So let me go ahead and come over here. So I've got some room to work here. And we'll take a look at the first problem. It says, a blueberry muffin recipe calls for half a cup of blueberries. A blueberry pie recipe calls for 3.5 times more blueberries. How many cups of blueberries are needed to make the pie? So what we're doing is taking that half a cup that's needed for the muffins and we're multiplying it by 3.5 because we need 3.5 times that much more blueberries. So our original problem is 1/2 times 3 1/2. Okay, they've drawn a model over here off to the side. So what they've done, takes me just a second to get these drawn in here. So they are showing, let me move our math problem over just a little bit so I have more room. They are showing that this is 1/2, right? If this is the whole, this is 1/2 of it. And let me make some boxes here so you can see this. They're saying that we have 3.5. So looking horizontally, this is 1, 2, 3.5 would go to right here. Okay, so they're showing 1/2 as a row and 3/2, 3 1/2 as a column. Okay? They want to know, when we did that, how many squares would we shade? So where do both of these numbers intersect? So it's going to be right here, all the way across the bottom. And it's asking us, that's where both of these sides touch, how many squares that we shaded. We shaded a total of 7. I know this may not be making sense in your brain right yet, but it will. So they are then looking at how many total that we shaded. This is part number 1 that we did here. Part number 2 says the shaded squares can be rearranged to form part of the model to the right. The model to the right looks like this. I'm just going to recreate it here. Okay, if I'm going to shade in 7 squares here, which is exactly what we have here, I'm trying to make a hole here. This fraction represents 1, 2, 3, 4, 5, 6, 7 out of 8 total. Right? These are the whole numbers. So we've got 7 pieces shaded, but our denominator, they're trying to show that this is a whole. It's shaded a little differently on your paper. So if that is the whole, then that becomes the denominator. So I have 7 pieces total. It takes 4 of them to make a whole. So they're showing me 7/4 right there, which is what they've got there on your page. Okay? When they want us to write this as a mixed number, they've broken it out like this. They're saying if you have 4 pieces all together, that's the same thing as 1 whole. And they're saying this side would be showing you 3/4 because you have 3 pieces shaded out of a possible 4 pieces. Okay, they're just trying to show you the visual of this. So that would be the 7/4 for number 3, right? Because you had 7 pieces and it took 4 to make a whole. Now they're asking us to turn that back into a mixed number. So we're going to take 7 and divide it by 4, because it takes 4 to make a whole. 4 goes into 7 one time. 4 times 1 is 4. You subtract. You take your remainder, which is 3, on top of the divisor, which is 4. So what they're showing us is that when you multiply these two numbers together, with all of this drawing and modeling, you end up with these two pieces. See them right here? 1 plus 3/4, which is 1 3/4. Now, I know that your brain is already thinking there's a much easier way to do this. I understand. I feel the same way that you do. But part of my job is to make sure that I teach you some alternate strategies to help you get there. Now, what your brain is probably doing was one of these. Let me just kind of as a side note come over here and draw what I think is already happening in your brain. I think that you started with the 1/2, and when you have to multiply that by 3.5, you probably started thinking, how can I do this mathematically? So I would probably see you changing this number into an improper fraction. So I'd probably leave that one alone because that one's pretty easy to deal with. And I would probably turn this one into an improper fraction. So 3 times 2 is 6, plus 1 is 7. So you would end up with 7/4. Here we are with 1/2 times 7/4. Well, when you multiply those fractions, seven halves. Hold on, I'm already making a mistake in here. Try that one more time. 1/2 times 7 halves. When you do that math, you end up with 7/4, which is the same thing, since we did it down here, is 1 3/4. So I know there are multiple ways to get to this. Today's lesson was asking you to use some of these visuals to help out. But I know that your brain is probably already working on this piece of it, and that's fine. Let's go ahead and practice this strategy one more time on the back. Ultimately, you'll be able to use whatever strategy works best for you. But for today, we're going to keep practicing what they're asking us to practice. So let's take a look at the next one. Okay, we have find the unknown in 1 1/2 times 3 3/4. Okay, they've done the drawing here to the right, which I know that you can see. I will not try to recreate here because it just takes us an awfully long time. So we're going to go ahead and practice with making those improper fractions like we did on the beginning of the lesson. So let's take 1 1/2, the mixed number, and let's turn it into an improper fraction because that's what it's asking us to do on this problem. So remember, we're going clockwise around. 2 times 1 is 2, plus 1 is 3. So 1 1/2 is the same thing as 3 halves. 4 times 3 is 12. 12 plus 3 is 15. 15/4 is 3 3/4 as an improper fraction. We can multiply. We're going to get 45/8 because we're just multiplying straight across. Now we can take this improper fraction and turn it back into a mixed number. Okay, so 45. Remember, this is kind of like a little division sign to remind you. Divided by 8. That's telling us we have 45 pieces. It takes 8 pieces to make one whole. How many times does 8 fit into 45? That would be 5 times. 8 times 5 is 40. When we subtract, we're going to put our remainder, creating a new fraction, with our divisor as the denominator. So 1 1/2 times 3 3/4 is 5 5/8. All right? We know that that one's in simplest form, so we are done with that math problem. Let's go ahead and practice down here at the bottom with number 1 in the guided practice. If we have 4 1/5 times 1/2, we're going to do the same thing. we're going to take this mixed number and turn it into an improper fraction. So 5 times 4 is 20. 20 plus 1 is 21. Denominator stays the same. And 1/2 is just fine for us to work with. We don't have to do anything to that one. Now you just have to multiply across. 21 times 1 is 21. 5 times 2 is 10. You're going to take this improper fraction, turn it back into a mixed number by doing 21 divided by 10. How many 10s fit into 21? That would be 2. 10 times 2 is 20. You're going to subtract. You're going to put your remainder on top of your divisor. So you end up with 2 1/10. If you have questions about this or need some more practice with it, you can email me at mvaw123@gmail.com, or you can get a hold of me through Class Dojo. Good luck!